Welcome to the new cyber frontier, bringing you the latest news and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
Welcome to today's episode of New Cyber Frontier. Today, talking about a topic that I think is very relevant, confidential computing. On today with me is Dave Singh with Intel. He is the confidential computing business development manager, but has a deep kind of level of understanding for this that I think comes across to everybody. We're not going to get into the technical weeds of the math bits and everything, but a good, what is it? So many people have asked or wondered what confidential computing is, heard of SGSX and what TDX now, so software guard extensions. But Dave, welcome today. Thanks for joining.
Hey, thanks so much for having me. Super excited to be here.
Yeah, definitely. So introduce the topic, kind of give us a little rundown on what your background is and how you got to where you're at with what you do here at Intel.
Yeah, so I've been at Intel for many, many years. Right now I'm in the office of the CTO and specifically focused on security technologies. Obviously, we have a number of technologies built into the silicon, and attached to those features built into silicon are software and services. Many of those are focused very specifically on security. My role is to evangelize the set of technologies that delivers on the confidential computing promise. And I work with software providers and CSPs and enterprises to say sort of spread the good word about confidential computing and related technologies, and then help customers implement those in their data centers and at the edge.
Okay. So if I now had to say, let me step back, I've never heard of confidential computing other than maybe the word. Give us a high level explanation of what that is.
Yeah, sure. So confidential computing is an industry term. It's kind of I think both a great one and a bad one. It's great in that, well, it really is what it sounds like. We're protecting confidentiality of your data and IP while you're computing. But it's actually a very specific implementation, right? So a lot of times I'll ask folks, hey, are you doing confidential computing? And everybody says, yeah, of course. I'm computing. I take many steps to protect confidentiality. Yeah. But actually, when the term confidential computing here means very specifically implementing hardware protections for the computation on sensitive data and IP while it's actively being processed on the server.
Okay. So hardware protections.
That's right.
Help us understand why that is important. I'm running my software on my computer, I'm running it on the cloud. Why, I don't even care about the hardware. Tell me about why that's important.
Yeah. So really it comes down to sort of think about encryption and when to encrypt and the benefits of encryption. As an industry, we've sort of been trained and embraced and deployed encryption on data at rest, right? So anytime your data is sitting on the disk, of course you encrypt it. You don't want bad actors to get access to it and get access to your secrets. So that's solved. Data at rest, we call it data at rest, encrypt it, solved. Same data in motion, right? Anytime we're going to send data from one device to another, we send it over an encrypted network connection. So solved, right? Everybody does that. That's been deployed. But as soon as you take your encrypted file off the disk, you send it across your encrypted network, it lands on the server. Well, the first thing that you have to do is decrypt it. And now it's in plain text, in memory, on that server, on that device. And so any applications, any software, any OS, any VM, any system administrator in the cloud who has access to that server can now potentially have visibility into your sensitive data that's been loaded into system RAM. And so that sort of last mile traditionally has not been encrypted. We have encrypted leading all the way up to the time it gets on the server. It's once it's decrypted and starts processing, that's when the good stuff happens. That has not been protected while in use. And so confidential computing is about using the capabilities of the hardware to protect computation while that data is actively being processed on the server.
All right. We're going to take a break. We'll be right back. We'll unpack that a little bit. Be right back.
Blockframe technology offers next-generation blockchain managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dave Singh of Intel. And that was a great explanation of confidential computing and kind of that last mile of when it's actually being used that most people probably don't think of. It's, when I'm storing it, whatever, but now it's being operated on. Other processes that are running on that system can look at it. Are we talking, our cloud provider and their systems that can look at our data? Is that something we're worried about?
Yeah, absolutely. I think everybody remembers sort of the Snowden revelations where government is able to go and subpoena your cloud service provider, for example, to get access to hardware. And again, that's all available to them. What confidential computing intends to do is make it so that even the cloud service provider who has physical access to the hardware that your workload is running on, even they cannot have visibility into the data while it's being processed.
Interesting. So you said what we're looking to do. I look for those key words. How adopted is this? Is it something that's new? Give us a little bit of the background history of it and where it's at as far as how many people use it.
Yeah, so confidential computing, Intel's been deploying that in our silicon products for close to 10 years now. We brought it to the data center about 5 years ago. So in cloud service providers today, like in Microsoft Azure and in IBM Cloud, and a number of other providers as well, have servers that have this capability built in. And then a number of them have also built services around this feature. Obviously, some customers go to a cloud service provider and access bare metal, in which case the capability is there for you to use as you like. Other CSPs have built entire services around offering confidential computing very specifically. And in that case, beyond the hardware, there's an entire set of sort of software stacks, VMs, for example, that provide this as sort of a one-click capability to protect your data while it's in that cloud.
Interesting. So when would I have to pay extra for this is what I'm hearing. If I talk to my cloud service provider, I have to pay extra to get a confidential computing capability?
Maybe. I mean, like so many things, it depends. So in terms of the feature in the silicon, it's just there. There's no extra charge for the feature in the silicon. Today, most cloud service providers that I'm aware of who are offering this are offering it as at no fee for the capability. Okay. I guess there are probably some who charge for it, but yeah, like I say, it depends.
Yeah. So not much cost to it. Is there some change in the operation performance? Why wouldn't we just have it on everywhere, every instance?
Yeah. So to implement confidential computing, Intel has a couple of different features in this space. One, the SGX, as you mentioned earlier, that's really targeted at protecting a specific application or even an algorithm within an application, right? It all comes down to what do you trust on that system. And for the most sort of security conscious customers and applications, you want to shrink the trust boundary to be as small as possible. And so maybe you only want to decrypt your data and allow a single algorithm to view that data. And in that case, you would run that operation inside of this SGX capability or inside of a secure enclave, as we call it. And to do that, there is some code modification typically that's required. You have to apply an SDK in order to call on APIs to say, when this application is running this algorithm, only run it in that secure portion of the hardware. And when you decrypt data, only send it encrypted over to that secure data and only open it inside of that secure enclave, and don't allow visibility to any other ingredient or person on the system. To do that, to take advantage of those APIs and send that processing to the secure enclave, there is software modification that's required. And so part of what I do and what my team does is provide the tools and help necessary for software developers to either build code from scratch that takes advantage of this, or modify existing applications to follow on those APIs. So in the case of SGX, with the tightest possible security, yes, there's new effort required.
New effort. And is there a performance change if I'm running in that mode?
Yeah, so there's a performance hit to sort of go in and out of that mode, right? Because you have encrypt and decrypt. And so once you're up and running inside of that secure enclave, you're running at line speed, right? You have the full power of the processor. But to get in and out, you pay some performance penalty. And so another thing that my team does is work with developers to help minimize the number of times that your application might go in and out. So chatty applications, they'll see a bigger performance hit. If you can get optimized to get in and do a lot of processing before you come out, then you see minimal overhead.
Gotcha. So you wouldn't continuously operate in this mode with your whole application, or else you can't use you can't interface with the externals, right?
Yeah, that's right. And you can, but you'll pay some performance penalty each time you come in and out. So ideally, what you want to do is bring as much data and have as strong of an algorithm as possible, and do all the processing there and get the ultimate result, and then come out.
Okay. So would you also try to do like an asynchronous where you run something in the background using that, and then you get the data to use it after it's been processed to do it later? So you try to do these things so that they're not impacting your performance would be the ultimate effort. Okay.
Exactly. And we provide mechanisms, right? Again, these are just sort of containers where processing can happen. And so you can have multiple secure enclaves that are in a system and can communicate with each other. And so you can allow processing to happen there and then have interfaces in between.
Okay. So if I think about it in terms of a cloud, and some people might know what a Docker is, would my whole Docker, that whole application, be able to run in a secure software guard extension? What safeguard SGX means?
Yeah, we do have ways to do that, and that's typically done using what we call a library OS. And a library OS is a mechanism that, well, you can essentially think of it as a wrapper for your Docker container. There's a number of library operating systems out there that do this. They're sort of specifically designed to provide this, allow you to implement SGX without having to modify your code, as I described, and drop in an entire container. One of these operating library OSs that Intel contributes to specifically is an open source project called Grameen. And so Grameen is intended to make it easy to adopt SGX. And in fact, one of the tools available from that Grameen project is a Docker container sort of utility, where you, as you described, bring your Docker container as is, run it against this utility, and now it will become optimized for SGX.
Okay. Interesting. So we're going to take a break. We'll be right back after we hear from our sponsors.
Blockframe technology offers next-generation blockchain-managed trust and security. Unique non-fungible tokens are used to secure software bills of materials to provide data quality and security for every transaction in your supply chain. Deploy advanced peer-to-peer product security, scale zero trust capability to millions of IoT devices, allow vendor tracking and accountability, and rapidly reset from compromise. Unchangeable, time-sequenced blockchain data provides next-generation security using machine learning trust algorithms and audit analytics. Start securing your supply chain today by contacting Blockframe at www.blockframetech.com.
Welcome back to New Cyber Frontier. On today with Dave Singh. An interesting conversation, the safe software guard extensions. And there's another piece that you've told me, the trust domain extensions.
Yeah. So
Let's talk
as I
about
mentioned,
the difference between those two.
yeah, totally. So as I mentioned, SGX is targeted on protecting a specific application or algorithm, and it's been out for a number of years and is available today in the data center. A new technology that was just launched earlier this year and is now sort of in private preview at various CSPs is called trust domain extensions. And there, the intent is not to protect a single algorithm, but rather to protect an entire VM. So in the case of TDX, what you'll be able to do is essentially, again, like in your example, bring your existing entire unmodified VM and simply select a TDX protected VM when you load that on your server. And in that case, the benefit, of course, is none of that modification or code surgery or library OS that I talked about is necessary. You simply turn on the capability, and now your entire VM is protected. So definitely a very sort of easy kind of lift and shift implementation. Of course, that's the plus. The drawback is the size of the trust boundary. So again, in the case of SGX, you only need to trust the algorithm, a specific algorithm itself. That's how tight you can get that down to. And an algorithm can be, you know, tens of lines of code. In the case of TDX, you're protecting the entire VM. So at that point, you have to trust the entire applications that you're running in that VM. You have to trust the guest OS. Everything that's part of that container is within the trust boundary. So very easy to get this protection. And again, that'll sort of isolate you from other applications and administrators who have access to the server, but you still have to trust the millions of lines of code that might be in your VM.
Okay. So and I'm trying to put my head around the difference between, the trust boundary. If I'm
Yeah,
outside, I'm stopped, and I'm looking at your VM running, I can't tell what it is if I'm the administrator on the cloud service provider.
that's right.
But as soon as I SSH into it, I have the same access as I would
That's
from a
right.
normal server. And that's
Yes.
so it's you have to then monitor or manage all the access into it, and you're just protecting the outside from people
That's
looking in.
That's
Okay.
right. All your best practices around access control continue to apply, but now you have much greater control over who can access. In the
Okay.
case of no confidential computing, you can have access control, but bad actors can come over the top by viewing memory directly. In the case of confidential computing, you sort of eliminate that ability to come over the top, and only now you're back to a space where only those who have the credentials that you're managing can have visibility.
Okay. So how would this be impacted by, say, a rootkit installed inside that VM inside the trust domain? Is it protected from the external
Yeah,
Once it's inside, how's that
once it's
impact?
inside it, yeah, a bad actor inside of a hardware protected enclave, it has full visibility,
Okay.
right? So that's exactly why you want to take into consideration the size of the trust boundary, right? So if you're building around, if you're building using SGX, building around a single algorithm, you can have, it's a lot easier to have confidence around what's running inside of that enclave. If you're doing the entire VM, of course, you have to go through the effort to ensure you don't have malware inside of your VM, but
Hmm.
it's a much bigger job.
Gotcha. Okay. So when it comes to that, most people think, okay, here's security. Why not? Don't we just implement the best and greatest security everywhere? Who wouldn't want to do this? If you're looking at an application that's a good candidate for this, who wouldn't want to?
Yeah, I, I think long term, my expectation is that all computing is confidential computing, right? This just like today, I talk about network security and on-disk security. Everybody does do it. Well, there was a time where everybody didn't do it. On my web browser, I have a lock now, the little lock, and it's on every site for the most part. But in the past, it wasn't. I think it's really a matter of the ramp and introducing the technologies. As I said, this SGX is in a number of CSPs today. We've been shipping that for a while. TDX just available starting this year. So it's not ubiquitous yet, but it will be. And once it is, I expect that's the standard way that you do computing.
Yeah. So would this be a good thing for privacy of operations of maintaining privacy, I guess, from your your internet service provider, your cloud service provider, that they don't have access to run algorithms and see the operations inside of your system and what's going on. So is that something that's also going to change in this paradigm?
Yeah. So there's a number of reasons why a customer is deploying this. We've talked today at quite a bit about protection from your cloud service provider. But the privacy of data from other parties is another key use case. So we see entire new businesses being built up around this idea of being able to collaborate with multiple parties, maybe even competitors,
Hmm.
bring data together and do analytics on it without exposing the data itself. So, key use cases I would talk about are in financial vertical, for example. One of the favorite confidential computing sort of poster children is detecting money laundering, right?
Hmm.
And money laundering, to detect that, obviously you need different banks to collaborate. You need to be able to do analytics for traveling funds across different accounts. And in that case, you're dealing with very sensitive personal data. You're dealing with sensitive business data. And as I mentioned, you're dealing with competing banks sharing data and to really track that money. And of course, in the real world, that was never really feasible. What
Hmm.
confidential computing allows you to do is bring that sensitive data, bring that data from competing parties, and inject it into this secure enclave and run analytics against it. Everybody can benefit from the sort of the response that comes out, the identification of money laundering without seeing each other's data.
So if your competitor could give you an algorithm that's locked in an enclave, put their data in it, and analyze it for problems without giving you access to the data, and
Exactly.
that's kind of where you're going with that.
Yeah, we can jointly do processing on the data without having visibility to it itself beyond the agreed upon algorithm.
Okay, so it's kind of like a polymorphic encryption type of supporting tool, or instead of how do
Yeah,
the two kind of work together?
yeah, that's right. I think certainly there'll be use cases that implement the two, but today, kind of the use cases I'm describing, it's an instead of.
Okay, interesting. All right, so it sounds like and I know this has been around, or at least in the works for a while. Uh, it's still not, in mass adoption, and that might be because of the software development curve, the learning curve to get new applications onto it. Is that what you're seeing?
Yeah, I think it's that, and frankly, it's awareness. Like we started at the very beginning of this, a lot of folks are not aware of confidential computing, and in fact, I talk to customers all the time who this idea of having to protect the last mile has not even been it has not even been on the radar yet. So I think
Gotcha.
it's a matter of education, and then of course ramping within the software community itself.
Gotcha. So, as far as education, you're with Intel. Is this technology specific to Intel? If somebody develops something for your software guard extension, does it work in a competitor's? Is there a standard there yet? How's that developing?
Yeah, confidential computing actually is an industry term, and in fact, there's a industry consortium, the Confidential Compute Consortium, and that has, gosh, I've lost count of the number of vendors, but the big names are all there. It's one that is doing the education and driving standards broadly. And I think as you go to your cloud service provider, or you go to your hardware OEM, or you go to your favorite software provider, they will have solutions that are represented by and have been brought to market through this confidential compute consortium.
Interesting. So, I hear a good need for it when you're thinking about cloud and shared data or processing resources. What about your on-prem? If I have my own servers, why and when would I use it in that type of environment?
Yeah, there's a few different reasons. Well, one is sort of just built-in suspender security, right? If any type of malware that might get onto your on-prem device that is able to succeed by getting an escalated privilege, that's something you want to protect against. And so if you're on-prem running your workload inside of a confidential compute enclave, then malware with escalated privilege can't get access to it. Um, from a privacy perspective, you may have company policies, or maybe you have regulatory policies that require that you have isolation between users or business units or what have you.
Okay.
So you can implement there. And then finally, a lot of use cases end up putting your IP in somebody else's infrastructure, even though it's on-prem. So, for example, I work with a number of machine learning vendors. Right? You spend millions of dollars training a model, and now you need to land that model in somebody else's infrastructure, at a hospital or in a factory, or what have you. You want to protect the model itself. You want to make sure that even though it might be on an appliance server sitting in that hospital or that factory or wherever, you want to make sure that your model is protected from whoever might have access to that device at the edge. And so again, you run that inside of a confidential compute enclave, it's protected from anybody except for whom you give that access to.
Interesting. So I could use that as a licensing model for my software and say, can I say my software won't run unless it's inside a secure enclave? Can I do those type of checks?
Yeah, of course. One of the features that I haven't talked about, it's sort of a key feature of the feature, is called attestation. So if you
Mhm.
think about this whole scenario that we're talking about is me as a sensitive data owner sending my data to a remote device, and then having confidence that I can decrypt it and process it there without it being compromised. Well, before I send that data there, I want to make sure that it really is landing on a server that has this hardware. I want to make sure that that hardware is up to date. If there's been any security vulnerabilities, that it's been patched properly. I even want to make sure that the algorithm that I talked about that's being protected in the enclave, I want to make sure that that algorithm hasn't been tampered with. Right? If I have two competing banks agreeing to work together and do something on the data that they can't see, They want to know exactly what's that scan is going to be, that analysis is going to be, and exactly what's coming out. And so they'll agree on the code. I have a capability that allows you to do all those checks before sending your data. So you get ready to send the data, you query the server. Are you genuine? Are you up to date? Is the software untampered? Once the response, you get a response that says, yes, this is as you expected, then you can go ahead and send your data NIP to that device. So attestation is a key feature of confidential computing.
Yes. So you can prove that somebody is doing the operation that you require and that their systems meet the specs. Interesting.
That's right.
Well, yeah, we're kind of reaching time. Is there anything else you would like to get out to our audience, how they can get a hold of you, how they can engage with you? Go ahead and do that at this time.
So as I say, confidential computing is an industry initiative. So check out the Confidential Computing Consortium. At Intel, you can go to intel.com, and we have all sorts of information about confidential computing and SGX and TDX, and case studies describing both software applications that have implemented the capability and customers that have implemented in their data centers.
Yeah. Well, I look forward to checking out some of those because that was something we didn't get to, but use cases is always a good thing to help it seat home with people. But they can check out those resources for that. And thanks so much for joining today, Dave.
Right on. Thank you. Thanks for inviting me.
All right. Have a good one.
Take care.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.